Volcanoes experience strain from pressures just like humans, but now, scientists say they can measure exactly how much physical strain is on them. Researchers monitoring the Yellowstone supervolcano in Wyoming have detected molten rock about 3 miles below the surface. While it is not dangerous, the scientists have warned that slight shifts in the environment around the volcano can add up and create significant change over time. The technologies they use can detect changes in volcanic strains smaller than the width of a hydrogen atom. Geodesists Mencin and Glen Mattioli say these measurements can advance scientists' understanding of volcanic activity. Their work, published this week in Yellowstone Caldera Chronicles, explains what these measurements can tell us about the national park's plumbing. Mencin and Mattioli fleshed out the comparison between strain put on humans and volcanoes in their report. It said, "We all know what it is like to experience strain.The pressures of everyday life can leave you feeling contorted and stretched. It turns out, volcanoes are no different, they experience strain as well. When a volcano experiences strain, it changes shape. Specifically, the shape of its subsurface rock changes," the authors said. This process is called deformation. A number of forces can cause deformation.A. If its magma pressure or the amount of water filling nearby lakes change, a volcano can be subject to deformation. These pressures can be measured by GPS technology combined with other tools, including borehole strain meters and borehole tilt meters. Scientists at a nonprofit based in Boulder, Colorado, called UNAVCO, Inc. maintain this equipment used to measure deformation levels throughout the western regions of the U.S. UNAVCO operates that are particularly sensitive to deformation of the ground surface and so have an important role to play in monitoring activity of Yellowstone, Mencin and Mattioli said. Borehole strain meters are able to detect changes that occur as far as 820 feet below the ground surface at Yellowstone. These changes do not have to be drastic for the scientists to pick up on them. Mencin and Mattioli said that they can be as minuscule as 1/10,000,000th of the width of a human hair or smaller than the width of a hydrogen atom, but they are important because over time these nearly undetectable shifts can add up to significant change. The report explained, sometimes these tiny strain measurements yield big surprises. The scientists gave an example of the work being done to illustrate how advanced the technology used to measure these changes is. Yellowstone strain meters are sensitive enough to record surface waves on Yellowstone Lake. Here's the surprising part, the strain meters are hundreds of feet deep and up to 12.5 miles away from the lake, yet these water waves can tell us something about Yellowstone's deep volcanic plumbing system, it said. Could an eruption at the Yellowstone supervolcano be prevented? Recent research found a small magma chamber, known as the upper crustal magma reservoir, beneath the surface. NASA believes drilling up to 6 miles (10 kilometers) down into the supervolcano beneath Yellowstone National Park to pump in water at high pressure could cool it. Despite the fact that the mission would cost $3.46 billion, £2.63 billion, NASA considers it the most viable solution. Using the heat as a resource also poses an opportunity to pay for plan. It could be used to create a geothermal plant, which generates electric power at extremely competitive prices of around 10 cents, 8 pence, per kilowatt hours. But this method of subduing a supervolcano has the potential to backfire and trigger the supervolcanic eruption NASA is trying to prevent. This USGS graphic shows how a super eruption of the molten lava under Yellowstone National Park would spread ash across the United States. Even besides the potential devastating risks, the plan to cool Yellowstone with drilling is not simple. And still, there wouldn't be a guarantee it would be successful for at least hundreds or possibly thousands of years. The authors said computer simulations reveal that magma under the Yellowstone caldera is affecting the lake's motion, and the strain meters confirm this. These independent observations agree with other instruments at Yellowstone, like seismometers, that indicate a zone of semi-molten rock starting about 3 miles beneath the surface, the researchers said. However, the measured volcanic strain is not dangerous, Mencin and Mattioli clarified. The measurements in the models that are based on the findings are examples of how sensitive instruments located on and just below the Earth's surface are helping us learn more about the deep secrets of Yellowstone and other volcanoes.